from the supply, the transformer, to our homes. Now, it is important to understand that electricity flows back and forth, and it flows from the source, our transformer in this case, all the way to the meter box and to our houses, or it could be a business establishment. Now, let me just take you through the meter box because it is important for you to understand.
Jaribu kudelete hapo kitu mrudhia.
We'll discuss about the gadgets that are installed in the meter box, and these gadgets are basically for ensuring that we have protection for electricity. Electricity travels in form of AC or alternating current. When it travels, then it means that we have to ensure that on its path there are safety gadgets or safety mechanisms that protect us from electric shock, as well as protect our appliances from any form of damage. Now, it is important for you to note that at this pole here, we have two conductors. These two conductors are phase and neutral. The phase can be either a red phase, a yellow phase, or a blue phase together with a neutral. This is a representation of a single phase. This single phase has one phase here. For our case, we are using the red phase to represent the phase that is dropping to this property here. We also have the neutral or a return path, because remember, for power to come to our appliances or basically to our houses, it has to go back through a return path. This return path is represented by the neutral. And now for this case, we have a drop cable. The drop cable has two lines in it, so that it is connected at the phase and at the neutral, which is required to power our homes. Now, at this point, it is important for you to note that there is this special part that is normally referred to as a PME. A PME in full represents protective multiple earthing. This point here drops all the way to the ground, and it is important for you to take note of this loop that is here on the PME. This loop is placed here so that whenever there is sinking here, there will be a compensation by that, so that instead of the sinking of the earth rod that is placed here, to pull this line here and eventually cut it, this loop here will be able to protect that, as well as it is a point where measurements will be taken by the power provider. That being said, it is also important for me to mention that this is an important earthing connection, whereby they communicate together with the earth connection that is on the property where we have the earth rod at the meter box, to ensure that all the charges that overflow to the ground travel all the way back to the source of course being the transformer. Now, this drop cable is very important in any electrical installation, because the power from this pole here or from this point here comes all the way to the property through the drop cable. A good drop cable should not be having any joints or any loose connections, whether at the pole or in the meter box. Now, when it gets to the cutout, it is important to ensure that the drop cable is continuing or it is complete without any joint in it. Once we get to the meter box, we have a special part here which is referred to as a cutout. You may have a double cutout or single cutouts. A double cutout has a connection for the phase as well as the neutral. Things get interesting at the neutral because that is where we tap the earth connection. The neutral does not break or get interrupted in any way because we have a bar. This bar will ensure that once the incoming neutral is connected and screwed at the output, the neutral also will be connected and screwed so that there will be no interruption. But when it gets to the face, there is a fuse connection here where we have the fuse carrier for the cutout. So that this point is where you can take the fuse carrier out and interrupt that flow of electricity. From there, then the current will flow all the way to the DP switch, or basically the double pole switch. Now the earth connection is tapped from this double cutout or this neutral section, whereby the neutral and the earth connection will be bonded, and then we will connect our earthing there. This earthing is connected through a 10 millimeter square cable. It can be green with yellow stripes or yellow with green stripes. At this point, the earth connection or that earth wire is looped to the metallic part of our meter board here. And then the same connection will go all the way to our earth rod. From there, the earth connection will go straight to the consumer unit. Now notice that the earth connection does not connect anywhere in the gadgets that I'm going to mention here, but it goes directly. The earth connection does not have any switching, meaning no matter what, the earth connection will not be interrupted, either by way of switching off the face or probably disconnecting the output of the neutral. So that is made so to ensure that the earth is continuing all the way to the pole and back to the source. Now let me talk about the face from the cutout. From the cutout, we have the double pole switch. This double pole switch will switch both the neutral as well as the face. From there, the power line will travel all the way to the energy meter. The importance of this double pole switch here is basically to activate the energy meter to ensure that there is flow of electricity all the way to the energy meter. Now, from the energy meter, there is a connection here where we have this energy meter being fed the face as well as the return path, the neutral. Most of the energy meters, especially the modern ones, the token ones, have an incoming face as well as an incoming neutral. And then there is an outgoing face as well as an outgoing neutral. In other meters, you'll find that the neutral has been looped. So the connection at this point really depends on the type of energy meter to be connected. From there, we also have a second DP switch, double pole switch. Most people do not have it, but this switch is important so that at that particular point, you have a switching for the consumer unit or now the house. So this switch is important to basically activate the electricity flowing from the energy meter all the way to the consumer unit. Now let us discuss about the consumer unit. Now for the consumer unit, I will have another representation that we will be able to talk about, and I have it right here. So let me just have it on my board. As you can see, I've drawn it using colors intentionally, and these colors actually represent the colors of the cables so that we will be able to get a clearer picture of the way that electricity flows. If you can see, for the neutral, we have the black wire. Remember, I said that for the neutral, for our country especially, or for our continent here in Africa, we use black for the neutral and red for the face. Green is a standard representation for earthing connection, and I hope where you are streaming this live from, you also use the same color. So for my presentation today, I'm using green without the yellow. And for these MCBs, I'm basically using this color blue. But let it not confuse you. The face is still red and the neutral is still black and our earth connection is still green. So let me basically explain. From now, the meter box, the wires are here or the cables are dropping here. Now, the size of these cables is something that is very, very important. For me, I will not use anything less than 10 millimeter square. That is the cross-sectional area of these wires. So for each cable, it has to be 10 millimeter square. That is for the face, for the neutral, as well as for the earth. The reason why we go with that dimension is to ensure that it actually carries the entire load that will be connected at the consumer unit without overheating or probably compromising the insulation. Now, for my consumer unit, I will have power come all the way to the DPMCB, or basically the double pole miniature circuit breaker, which other continents refer to it as an isolator. The good thing about it is that it will switch off electricity supply to all of these circuits that are served by these MCBs, miniature circuit breakers. Now, that is the main function of the double pole miniature circuit breaker. I will also have a surge diverter here, and I can as well have what we refer to as an RCCB or an RCD. The main purpose of that is to protect the user against an electric shock. It will detect when there is a flow of charge from the face to the ground and immediately interrupt the entire electricity flow in the house. We will talk more about that. But for now, let us talk about the surge diverter. Surge diverter is basically connected in three ways. There are a connection for the neutral, the face, and the earth. So the face and the neutral will simply be connected to the face and the neutral, and then the earth connection will be looped to the earth wire. So that in case there is any surges that will happen in that line, this surge diverter will simply cap off and take it to the earth connection, which will then travel to the ground. The earth wire or the earth connection in that installation must be perfect to ensure that these excessive charges or the surge that happens in that installation finds an easier route to travel all the way to the ground. From there, the neutral now will be connected to the double pole miniature circuit breaker to the neutral bar. This connection is very, very important because all of the circuits will rely on this line here to ensure that the service of the neutral from the neutral bar is firm and is continuing. And then from there, we have the looping of all the MCBs, miniature circuit breakers, or basically the circuit breakers to these phase connection or the live connection that is found at the double pole miniature circuit breaker or the isolator or the main switch. Now from there, after we loop all the MCBs, then we will detect or determine which circuit is it that we connect to what MCB. Mainly for the lightings, we have 5 ampere. So all the lightings in that installation will be connected to the 5 ampere MCB. This I'm referring to an installation such as a normal home or a normal house that does not go beyond probably 3 bedrooms. But we can have a 6 ampere MCB or a 10 ampere MCB depending on the load that is connected there. And then we have the sockets. All the sockets can be connected to a 20 ampere MCB. In the event that we have a ring circuit where we have a lot of sockets, then we can consider a bigger MCB, also depending on the machines or appliances connected to those sockets. But in this case, we must have separated the sockets so that we ensure that they have different circuits here so that we can have several circuits coming to different MCBs here. And then we go to a heater, could be a boiler or probably an instant shower head that draws a lot of current. That one will be connected to a 32 ampere MCB. Can also have a cooker or an electric cooker or the circuit that is in the kitchen where a lot of appliances that draw a lot of current will be connected to it. These other MCBs can be reserved for any expansion or in case there are other circuits that will be created. A consumer unit must be bigger in size at the point of installation and also allow for more provisions of pipework so that in case there will be need to have more gadgets in this consumer unit, the customer will not do a surface wiring or start cutting or chasing the walls, but all the conduits will be here, as well as more space to add more gadgets such as the RCD, the residual current device, as well as the many circuit breakers that they may want to have. Another important point to note is the neutral bar. At the neutral, as you notice, there is no switching apart from what we switch at the MCB or the double pole MCB. From there, the connection goes all the way to the respective circuits. And this is made so because when there is a loose connection at the neutral line or the return path, then it means that appliances will strain to receive electricity, and that will compromise on their performance, as well as it may damage them because that will increase the voltage supply to these appliances. So the neutral bar is important because it ensures that there is no loose connection. When you are doing this installation, especially at the consumer unit, it is important to always ensure that these screws are tightly done so that these circuits do not strain in getting their power, especially for the high powered appliances such as a cooker, any heating appliance that you might be having at home, or any heavy load for that matter. Now, also at the MCBs, the connection must be tight. The same applies on the earth bar, where you must ensure that the connections here are very tight. Another mistake that you might have to do on this earth bar is to screw the insulation of these cables. The cables must not be screwed on the insulation, but on the copper wires. This will ensure that in case there is any excessive charges, let's say from any appliance such as a cooker, all the charges will find an easier and safer path to travel very fast from the metallic surfaces of whatever appliance is all the way to this earth bar, and then from there travel through this cable all the way to the meter box and finally to the ground through what we refer to as an earth rod. So the size of this wire or this cable is still 10 millimeter square. Now, for those specific circuits, let's say for the light, the socket, the heater, and the cooker, also the size of the cable matters. For the lightings, you go with 1.0 millimeter square cross-sectional area. For the sockets, it is 2.5 millimeter square, but again, it matters which socket is connected. For the kitchen sockets, it's good to have a 4.0 millimeter square wire. When it comes to the heater, it is better to consider 4.0 millimeter square and nothing less than that. So this refers to a heater such as an instant shower head heater, and an electric cooker should also be served by 4.0 millimeter square, and any heaters such as under-sink heaters really must be connected to 4.0 millimeter square. Now, when we get to every connection, like let's say it is a neutral uh, uh, going to a respective circuit, like let's say for the light, also the gauge of the matter is the gauge of the wire is equal to that of the face as well as the earth, meaning if you go with 4.0 millimeter square for a cooker and that is the face wire, you must ensure that for the neutral, the black wire, it has to be 4.0 as well as the earth. There are so many people who make a mistake where you find that they go low when it comes to either the neutral or the earth connection, whereby you'll find someone has used 4.0 millimeter square face for the cooker. When it gets to neutral, they go down and use a 2.5 millimeter square. And sometimes for the earth connection, they even go lower and connect a 1.5 millimeter square for the earth. Most people don't take the earth connection with a lot of weight. It is important to note that if you are installing the wires or the electrical connection for the cooker, all the three cables, the earth connection, the phase connection, as well as the neutral, all of them must be the same size, same material, which is copper, and the insulation also matters. So for the choice of cable, ensure that you go with copper, you go with good wires which have proper insulation, as well as you have cables that are able to withstand the current that that specific appliance draws. Meaning, if it is a 4.0 millimeter square wire, it has to be 4.0 and nothing less than that. Apart from that, it is important to ensure that the size of the MCB that you are using will go hand in hand with the current being drawn, so that if at all there is a problem in that specific appliance, then the MCB will trip. MCB will trip so that it can save the appliance from any damage that is electrical. Also, if at all there is a problem whereby there is a short circuit in the appliance and probably there is someone using it, this MCB will trip so that it can even save you from any damage or probably save the home or the property from fire issues. When it comes to electrocution or electrical injuries, it is important to have the specific gadgets here which will protect you. Now, lastly, let me emphasize on the aspect of safety on the electrical installations. As much as you have good or quality gadgets that you have on the consumer unit, one of the things that will mess you up as an electrician or the owner of a property is if you will have all these connections loosely done, or probably you don't have regular inspection. All the electrical appliances or installations must be regularly checked to ensure that there is no problem as you continue using your appliances. At the point of piping, it is important to ensure that all of these cables go through a conduit. In that conduit, if at all there is a point where we have junction boxes or the circular boxes, it is important for you to ensure that all those boxes are covered with circular covers so that you do not have the cables being exposed to rodents. That was my time for today. I hope that you have learned a thing or two when it comes to this. I will still give out more information in regards to this type of installation, which we refer to as domestic house wiring. That is for use of a single phase connection. We will also be doing it practically on our practical board, as well as the ground where we have done wiring or electrical installation for a 3 bedroom, and I've shared a couple of videos and I will still share more. Thank you so much for tuning in. It was a pleasure hosting you in this live stream. My name is John and this is Top Heights Electricals and Electricians. See you in the next one.